All right, so we're now taking a look at just simplifying some of these radicals in ways that we haven't done before. And there's some actual different layers to it that we can look at, but we're going to look at it the nice simple way today, following up on the work we've been doing. So like for this first one, I would start simplifying it by turning it into a fractional exponent, right? So that would be x to the power of 24 over what? 2, because remember it's a square root, there's an assumed 2 if there's no number written in. Does 24 over 2 simplify? Yes, it does, right? Obviously 24 over 2 is 12, so that whole thing just ends up equaling x to the 12th. That's it, that's all you got to do for that one. Take a look at the next few. Go ahead and do those on your own first, really quick. All right, so the next one then, we do it the same kind of way. We're going to have x to the power of 24 thirds in this case. And 24 thirds, that just equals 8. So this is going to be x to the power of 8. All right, next one, same idea. We get x to the 24 fourths. And that reduces. That comes down to just be x to the power of 6. Boy, aren't these easy? Then the next one, x to the power of 24 fifths. And we have a little bit of a problem. That doesn't reduce. When you end up with something like x to the 24 fifths, we still can, however, simplify this. Okay? And I want to show you how, which I take a deep breath before doing because it means I got to write out a lot of x's here. We are going to have 24 x's. There's 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We are looking for the fifth root of that. If I want to know the fifth root, I basically am circling how many sets of 5 can I pull out of this? Because if it is the fifth root like that, what is the fifth root of x to the fifth? Just x. So it's like circling pairs when we're doing that with numbers. You can do so with bigger groupings. And so then, how many groups of 5 can I pull out of this? Notice there's 4 of them. Oops. There we go. And so on the outside then, I'm going to have 4 x's. On the inside, is anything left that I did not circle? So, how many are left uncircled at this point? Yep. There's a grand total of 4 of them left uncircled. And so we still have 4 x's left inside. Well, we don't want to leave it written like that, right? Because x, 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 and then fifth root of x, 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 x. Not good. So what's a shorter way to write 4 x's multiplied all together? X to the 4th. And then we have our fifth root there still, because remember, our fraction didn't reduce past that. And so then it's going to be the fifth root. Don't forget to label it as fifth root. When you're like typing this in as an answer like into WAMAP or something, you have to remember to actually say which root it is. Square root won't work. On the inside, we still have x to the 4th. And so this would be considered the final answer. Now, how could we get there quicker without having to write out 24 x's? What is 24 fifths as a mixed number? Well, in order to answer that question, you'd say, how many times does 5 go into 24? 4, right? Notice, 4 x's on the outside. And what's left over after I pull out those 4 sets of 5? 4 fifths. 24 fifths as a mixed number is 4 fifths, which means that if I would just want to do this by that method, this would be x to the power of 4 and 4 fifths. And I'm writing out a couple extra steps here just to make it clear where each part comes from. So that's x to the 4th and x to the 4 fifths, which is why it is then x to the 4th, and then the fifth root of x to the 4th. In this case, both exponents just happen to be 4. That's just happenstance here for our example. There's nothing magical that's going to say they'll always be the same.